All right, so today's focus is actually solving exponential equations and solving logarithmic equations. So the warm-up asks us to evaluate each logarithm. Now, normally, if we see two logarithms, we would try to simplify them using our properties. But you'll remember that there is not a property for when the two logs are being multiplied together. If this were addition, then yes, we could go ahead and multiply the 81 and the 3 together. But since it's multiplication, we cannot use properties. So if they want you to evaluate each, you're going to evaluate each one separately and then multiply your answers together. So for example, log base 9 of 81, remember we would set that equal to x changed to exponential, so this would become 9 to the x power equals 81. And then you have to think, 9 to what power gets me 81, and that would be 2. So that logarithm is equal to 2. Now I do the other one. Log base 9 of 3 is equal to, let's say, y, just have a different variable. Change to exponential, we'll have 9 to the y power equals 3. What would the value of y be? 9 to what power would get me 3? Ashley? 1/2. If the number's getting smaller, it's either 1/2, 1/3, 1/4, something that is a root. So this would be a square root, which makes this 1/2. And then 2 times 1/2 will get me that the answer is 1. Okay, number 2 asks us to use our rules from chapter 7 with our rational exponents, because you're going to see some stuff like that today. So if I wanted to simplify this, what would I do first? Good, we have a negative exponent. We'll move it to our denominator and we'll make it a positive exponent. And then how do I take 125 to the 2/3 power? Jade? No, other way around. Cube root and then square that. So this is really the cube root of 125, and then we'll square that. So remember, the denominator is your index, the numerator is what's being done to that. So the cube root of 125 is 5. 5 squared will get me 25. So the answer will be 125. All right, so today we're solving equations that have exponentials or logarithmic. So an exponential equation by definition is an equation in the form b to the cx power equals a. So the main thing that makes it exponential is that the variable, the x, is in the exponent of the equation. So you can see these are some examples of exponential equations. Now normally, if we solve something, to the 3rd power, we would do the cube root of it. Or if we solve in the 4th power, we do the 4th root. We do the inverse. Okay, the inverse, if you remember, of an exponential is a logarithm. So just like adding and subtracting are inverse operations, or squaring and square rooting are inverse operations, an exponential and a logarithmic are inverse operations. Okay? So if we see an exponential equation where there's a variable up top, what we can do is we can take the log of both sides. Now you can take the log base 10, the log base 2, the natural log. Take any type of log you want. But the easiest one to do because of our calculator is log base 10, which is our common log. So to solve this, we're going to, I guess I would say we're going to isolate this part first. So isolate the exponential part in case there was like a plus or a minus after it. And then we are going to take the log of both sides. When I say log, I'm saying the common log base 10. So this will become log base 10 of 5 to the 2x power equals log of 16. Remember, you have to do it to both sides, just like if you were undoing addition with subtraction, you would put it on both sides. And if you want, you could put in the base, but you don't need it. But maybe just for your first note example, so you know, like that's a log base 10. Now we're going to simplify using our properties from last week. So we can use the power property, which says the exponent will come out front and become a coefficient. So now I have 2x times log 5 equals log 16. And remember, log 16 and log 5 are just numbers with a bunch of decimals. So now we're going to solve using inverse operations. We see multiplication here, 2 times x times log 5. So the inverse would be to divide by 2 and by log 5. So you can do them separately or you can do them together. So I'm going to divide by both of them, and when I do that I am going to group them with parentheses since I have two numbers. 2 times log 5. So that's going to cancel out my 2 and my log 5. So I just get x. This part is all going to go into my calculator. You do want to make sure you put parentheses since the denominator has 2 elements. And we can just use the log button because this is log base 10, which is why I said it's your best option. So we'll type in log 16. Now you do have to, especially us with the older calculators, close your parentheses after the 16. Then divide, and we'll put parenthesis 2 log 5. You actually have to close your parentheses once for the logarithm and then a second time for your parentheses set. And we'll get 0.86, and they tell us to round to the nearest 10,000. So that would be 4 decimal places, so 0.8614. Now, it tells us to check our answers. So we can leave that long number in our calculator. And if you'd like, you can store it for x, which is what we normally do. You also could use the answer button to plug it in. But let's go ahead and store this for x. So STO button right above the on. And then we'll press the X button, which is right underneath the mode, and hit enter, and it will store that value in for x. And then we can check by raising 5 to the 2x power. So 5 caret. Now again, since it's two things, 2 times x, you'd want to group them with parentheses. So 2x. And we better get 16. So we know we got it right. All right, next one, exponential also. So we'll start by taking the logarithm of both sides. So log 3 to the x equals log 4. Use your rules for logarithms. The x can come out front. And this one is even a little easier because we'll just undo multiplication with division. You don't have to group the denominator since it's just log divided by log. And then this will go into our calculator. Make sure you close the parenthesis though after the 4. And so we'll get 1.2619. Let's check it real quick. Store that in for x. 3 to the x power gets us 4. All right, now the last one has a binomial in the exponent. So same process, just going to be a little bit different at the end. You may want to put parentheses around that to remind yourself that that is x plus 4, the quantity. So again, we're going to solve this by using inverse operations. So we'll take our logarithm of both sides. Use our power property, and make sure you do leave this in parentheses this time. Now you have options. You could distribute the log if you wanted to. I don't recommend it because then you have multiple logs. But you could distribute. I would probably choose to undo first multiplication with division. And then you have x plus 4 equals this. We'll have to subtract 4 at the end. Now I'll just probably leave that like this because I don't want to have to write out all those decimals. And so I'll just put a -4 like at the very end of that problem. And so we'll evaluate the logarithm's division first and then subtract 4 from our answer. So log 101 divided by log 3. Make sure you hit enter first and then subtract your 4. So we should get 0.2009. And we'll check it real quick, store that in for x. And you guys obviously will like this because you'll get to use your calculator on your test. .101. Now we got it right. All right, now the next part of the lesson is the change of base formula. So the change of base formula is really useful for those of us that have the older calculators that only do a base 10. So we can change the base of a logarithm to be a base 10. Those of you that have a newer calculator, you can do the log of any base by just pressing the math button and scrolling. But for us, those of us with the older calculators, you would need to use what's called the change of base formula. So what this allows us to do is change the base to any base that you want, but we usually will change it to a base 10. So for example, if you had log base 2 of 6, and you wanted to evaluate that in your calculator, but our calculators, most of ours only do log base 10. You will use this formula, which is to take the log of the new base that you want, which will just be log base 10, of the bigger number, what you're taking the logarithm of. So this would be log 6 divided by log of the base, log 2. Now they put this little c there because you can change the base to be anything you want it to be. We just usually choose base 10 because that's the common base in our calculator. So if you type this in your calculator, that will get you the answer of log base 2 of 6 without having to have a new calculator that does that. So on the back, we're going to practice this formula a couple times. And we're also going to take it a step further, and we're going to convert a log base 6 to a log that has a base of 3. All right, so first of all, let's use, and those of you with the new calculator, you are welcome to just use the calculator buttons to evaluate this. But those of us without it, to evaluate log base 6 of 12, we're going to use the change of base formula, which would be to take log 12 divided by log 6. And then typing that in our calculator, we'll get our answer. And we will have to round it for our paper. Well, I guess we could write them all out, but when we go to change it to base 3, we're going to want to leave that answer. So I'm going to round it to the nearest 10,000 like we did on the front. But whenever we do the second part, you will want to leave this in your calculator. All right, so evaluate, that's done. Then convert log base 6 of 12 to a logarithm in base 3. So what we're going to do is we're going to take this log base 6 of 12, and we want to set it equal to log base 3 of, let's call it x. So we're going to convert this so that it stays the same value, but it no longer has a base of 6, it'll have a base of 3, which means this number is going to change. So what we can do then is we can plug in the answer we found from the top part. We found out that log base 6 of 12 is this number. Okay, so we'll get rid of this and replace it with this value. And then remember, to solve logarithmic equations from our last quiz, we would change to exponential form. So let's say plug in, and then we will change to exponential form. So this will become, the base stays the base, remember? So this would be base of 3 to this power equals x. It's kind of not counterclockwise like normal because log's on the other side. But the base of the logarithm becomes the base of the exponent. So this will be 3 to the 1.3869 yada 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 power will equal x. So in order to do this in our calculator, I want to take this big long number and I want to store it for x. And then I'm going to raise 3 to that power. So I'm going to raise 3 to the x power. So we'll get this answer. And let's go ahead and just round the nearest 10 thousandths again. So we'll do 4 decimals. 5888. Right. Now that's not our final answer. Remember what the answer was is log base 3 of x. So just take this and plug it back in for x. So it would be log base 3 of 4.5888. So we've changed this expression to be log base 3. It'll still have the same value. All right, so you guys can try the next one. I'm actually going to start passing out your test folders, just 3.7227 for our evaluating the log. Most students are fine with that, but then changing the base gets a little bit confusing. So we're taking, again, our log base 5 of 400, and we're going to change it to log base 8 of something. And if you don't want to use x, if you want to use a different variable just because we use x, you can use y or z or whatever. Let's just put 1. Again, you're going to take the answer that you found and you're going to plug that in because the log of base 5 of 400 is this big long number. And then you're going to solve out for y. So we'll change this to exponential form, take the base, raise it to the other side's power, and that will be equal to y. So this will be 8 to the 3.7227 power is equal to y. So I'm going to take that answer that was in my calculator, store it for x, and then I'm going to take 8 to the x power to get my value, which is 2,301.1171. Take that and plug it back in for y to get log base 8 of what? So this would be log base 8 of 2,301.1171. How many of you got that? Awesome. All right, the last few are actually pretty easy. We are going to solve logarithmic functions, which can be done by changing to exponential and then just solving your exponential. So, if we don't see a base, it's understood that this is base 10. So you probably want to insert that into the problem even though we normally don't write it. Because when we change to exponential, you need to know what the base was. So we'll change this to exponential form. Which will become 10 to the 5th power equals 3x plus 1. Evaluate 10 to the 5th power, which will be 100,000. And then just solve a two-step equation, subtract and divide. If you want to check your answer, doesn't tell us we have to this time, you could by actually typing in 3 times 33,333 plus 1 and you'll get 5. So you could store it back in for x if you want, or you could just plug it in. Next one, same thing. We have a common log, so this is a base 10. So this will become 10 to the negative 1 power equals 7 minus 2x. Now 10 to the negative 1 power is 1/10. That'd be 1 over 10 to the positive 1. So if you want to do that as a decimal instead of a fraction, like 0.1, you could. That's up to you. But it looks like I left it in fraction form, just to practice fractions, but you could do either. So we could change this to be 0.1. And then just subtract 7 and divide by negative 2 and see what we get. And we get an answer? Actually? Negative what? Yes. Actually, I got positive. Because whenever you subtract the 7, you'll get a negative, and then whenever you divide by negative 2, the negatives would cancel out. So you get a positive 3.45. Or you could have 69/20ths if you did it as a fraction. Remember, the only time you have to leave it as a fraction is if the decimal doesn't stop. And then our last few are going to be combining properties of logarithms with solving. So we're going to use our power property, our product, and our quotient. So we see the number out front. That's going to go back up to be an exponent. So this will be log of x squared minus log of 3 equals 2. How do we simplify when we see two logs being subtracted? Divide them. So this will become log of x squared divided by 3. So that's using our quotient property. And now you're going to solve just like we did above. Inserting an imaginary base 10, change to exponential, 10 to the second power equals x squared divided by 3. Evaluate 10 squared is 100. And then how would I solve this for x? So the first thing I have to do, Jade? Good, I see division of 3, so I will multiply by 3 to get 300 equals x squared. And then I'll square root. And just for fun, let's leave this in simplest radical form. What would I break it down into? 300. The largest perfect square that gives in. Abby? What? 100. 100, yes. So we'll break this into the square root of 100 and the square root of 3, which will be 10 root 3. Technically positive or negative, but you're not going to take the log of a negative number. You'll get that error. Why don't you guys see if you can do the other two while I'm passing back your quizzes, and then we'll go over them.